Hello, welcome to Einstein's Mechanics. In this episode, we are going to solve problems on parallel plate capacitors. So we have about 3 examples to solve. In problem 1, we have our problem statement. So calculate the capacitance of a parallel plate capacitor having, so in this problem, we are having capacitor with 5 plates, each 30 millimeters by 20 millimeters, and it is being separated by a dielectric of 0.75 millimeters thick, having a relative permittivity of 2.3, and we have the permittivity of free space as 8.85 to the power negative 12 farad per meter. So this is our problem. Let's look at how best we can solve this. So let's write down our parameters. First, we are to calculate for the capacitance C. We don't know. And we have n number of plates. So n number of plates from the question we have 5. And each is 30 millimeters by 20 millimeters. This is the area. So our area is 30 mm by 20 mm, and this is going to give us 600 mm square. Are we okay? So we have our area. Now our dielectric thickness D, which is the distance between the two plates, is 0.75 millimeters. So we have to move that to meters. The area too, we will convert that to meter square. Now we have 7.5 to the power negative 4 meter squared. For this is the distance, so that will be meters. Are we okay? Now we have another parameter given as the relative permittivity, epsilon r, which is 2.3. We also have free space permittivity as 8.85 to the power negative 12 farad per meter. Now, with this information given, the capacitance of a parallel plate capacitor with n number of plates can be calculated from this formula. We know our C is equal to, now, the permittivity multiplying n minus 1, and we have our area on the distance between the plates. So without this, we can calculate our C. Let's put in the values. Our relative permittivity is 2.3. The permittivity of free space, that is 8.85 to the power negative 12. We have 5 number of plates, so that will be 5 minus 1. And our area, 600 millimeter square. And we are to convert this to meter square. That is going to be 6 to the power negative 4. Everything is over the distance, which is 7.5 to the power negative 4. And when you use your calculator, you are going to get the capacitance from this information as 65.14 times 10 raised to the power negative 12 farad. So in terms of prefix, we are going to get 6 points or 65.14 picofarad. So this is the capacitance of the capacitor. Let's look at our example 2. Problem 2. The capacitance of a parallel plate capacitor is 100 picofarad. This is 1000. So we have the capacitance to be 1000 picofarad. It has 19 plates, each 50 millimeters by 30 millimeters, separated by a dielectric of thickness 0.40 millimeters. Now determine the relative permittivity of the dielectric. We have the permittivity of free space given. So this is also simple. Let's start by writing down our parameters. From the question, we were given the capacitance of the capacitor, which is C, and that is 1000 picofarad, and pico is 10 to the power negative 12, that is farad. What other information? We have 19 plates, which is N, number of plates is 19. Each separated by 50 millimeters by 30 millimeters. That is our area. So our area is going to be 50 mm by 30 mm. And this is going to give us 1500 mm square, millimeter square. And we are also having the thickness of the dielectric. That's our D also given. So the thickness D is also giving us 0.40 millimeters. And in terms of meters, we are going to have this as 4 to the power negative 4 meters. We also have from the question the permittivity of free space given as 8.85 to the power negative 12 farad per meter. So we are to determine the relative permittivity, epsilon R. Now we know that if we have n plates of capacitor, now we are going to follow this formula. Our capacitance is equal to epsilon R. We also have this n minus 1, our area, everything on the distance d. So looking at the parameters, we are looking for epsilon R. We have the other parameters. So let's make this the subject. From here, we are going to get our epsilon R to be equal to capacitance multiplying the distance, everything on epsilon naught. We have our n minus 1 and our area. So with this, we are able to make this the subject. Let's put in the values. This is going to be the capacitance, which is 1000 picofarad, 10 to the power negative 12, and the distance, which is giving us 4 to the power negative 4. Everything on free space, which is 8.85 to the power negative 12. We also have n minus 1. We have 19 plates. So 19 minus 1 multiplying the area. The area is 1500 millimeters square. So if we are to convert this to meters, then we are going to get our area as 1.5 to the power negative 3. Are you okay? And with this, we are going to punch and have our relative permittivity of the material as 1.674, or you can say 1.67. It has no units. Are you okay? So this is the relative permittivity of the material for the dielectric. Now let's look at the last problem, which is problem 3. A capacitor is to be constructed so that its capacitance is 4250 picofarad and to operate at a PD of 100 volts across its terminals. The dielectric is to be polyethylene, which is the relative permittivity of the polyethylene, which is the dielectric material, is 2.3, which after allowing a safety factor has a dielectric strength of 20 megavolts per meter. Now find the thickness of the polyethylene needed and B, the area of the plate. So let's write down our parameters from the question so that we can see how best we will try. So the capacitance is given, which is 4250 pico, 10 to the power negative 12 farad. Are we okay? We also have the PD, which is the voltage across its terminals, to be 100 volts. We also have the terms given the relative permittivity of the polyethylene as ER, which is also 2.3. Now, from the question, we also have dielectric strength or dielectric intensity, which is our E. From the previous episodes, 20 mega. Mega is 10 to the power positive 6 volts per meter. Are we okay? Now, we are to calculate for the thickness of the polyethylene, which is D, the thickness of the dielectric material. We don't know. And we are also to calculate for the area of the plates. We also don't know. But this is very simple. Our A part, since we have the dielectric intensity E, checking from the unit, it is volts per meter, meaning our formula for the intensity is going to be a certain voltage over a certain distance D. Are we okay? So right from here, we can make the D, which is the thickness of the dielectric, the subject, and this is going to be voltage on intensity. So if we put in the values, our D is going to be, this is 100 voltage on intensity, 20 mega, 10 to the power 6. And if we punch this, we are going to have 5 to the power negative 6 meters. This is meters directly because the megavolt meter is already in meters. Are we okay? They are in their standard unit. If you want to work the distance in millimeters now, you can convert this to millimeters by multiplying it by 100. So our D can also be equal to 0.005 millimeters. Are we okay? So now we have the thickness of the polyethylene needed. Let's look at the B part. The B part says we should also find the area of the plates. So now from the capacitance formula, we can also find the area. This, we don't have n number of plates, so we assume there are 2. And if it is n minus 1, where n is 2, we are also going to have it as 1. So our formula is still going to be epsilon naught, and we also have the relative permittivity, we have the area, everything on the thickness of the plates. Now we are interested in the area, so we can make the area the subject. Here our A is going to be capacitance multiplying the distance, everything on that. So we have the formula. If we put in the values, then our area is going to be, now the capacitance, which is 4250 picofarad, and our distance from the A part. Since we are working in millimeters, we are going to take this part. We are working in meters, which is the standard unit. Let's take the meters part to work, because already we can see that all the units are in the normal standard units. So our distance is 5 to the power negative 6. So it is best you get your A part correct. Once you get it wrong, it is going to affect the B part. Everything on the free space, which is 8.85, you should get it off head. Even if you are not given, you should know it by the relative permittivity, which is 2.3 from the question. And with this, if you punch it on your calculator, you are going to get your area in terms of meters as 1.044 to the power negative 3 meter square. Now, if you want to convert this to millimeters, then our area is also going to be, meaning you are going to multiply it with 100 or 1000 square. Converting from meter to millimeter, you're going to multiply. So this is 1000 square, and that is going to give you 10.44. I'm working in centimeters, so that is centimeter square. Are you okay? All right. So now This is the final answer for the area. If you don't want any problems with the centimeter, the meter, you can stick to one unit, which is the meter square. Are you okay? So this is the end of the problem 3. Thank you for watching this episode. Check out for the next episode as we discuss capacitors in series and parallel arrangement. Please subscribe to the channel, like the videos, and drop your comments. See you in the next episode.